Hi there, Mr. Sutton here, bringing you the IM3 Honors 7-8 Extra Practice Number 1 solutions on midline and phase shifts. For this one, we're trying to get an equation for this graph. So I'm going to do this for a sine function, and then I'll also write a cosine version of this. So for the sine version, we have in general a sine of bx minus h plus k. That's kind of our general setup here. So we need to find a, b, h, and k. A, the amplitude, is going to be half the height. It's how much we're going up and down from the middle. So for that, I'm going to do 2 minus negative 2. That's the whole height. All of that divided by 2. So that's just going to be 2. All right. Next, I need to do the b value. That's going to be 2 pi divided by my period. Now, my period here, to go from one part of the wave to the same part, how long does that take? Looks like, let's see here, about 8 grid lines, and each grid line is worth 1/4 of a pi, so that's going to be 2 pi for the whole period, which means that our b value is going to be 2 pi divided by this p value of 2 pi, which comes out to 1. All right. For the h value, this is where the sine wave would start. So we're looking for middle of the wave going up, and that would be our h value if we're writing a sine version of this equation. Middle of the wave going up is right here at 5 pi over 4. So that's our h value for sine is 5 pi over 4. And now for the k value, that's going to be the midline, the average of the top and the bottom. So if we do 2 plus negative 2 divided by 2, that's going to be 0 over 2, which is just 0. Or you could just look and see that the midline is indeed 0, but you can do the average as well. Plug in all that in now. We're going to have y equals 2 times the sine of 1 times our parentheses. So we'll just write sine. We don't have to write the invisible 1. In here we have an x minus 5 pi over 4. And plus k, we're doing plus 0, so we don't have to write anything there. And this one is finished. Now, if I want to write a cosine version of all of this, here's our cosine formula, basically the same as sine, but with a cosine there instead. And all the information is pretty much the same in terms of a, b, and k. So everything I had already. The only thing that's changing is the h value. Cosine, we're starting at the top of the wave. So that's going to be, there's 2 spots here. You've got positive 7. You've also got, or actually this is 7 pi over 4. You've also got negative pi over 4. I'm going to go with negative pi over 4 just because it's closer to the y-axis there. So when I write my formula, I still have a 2. Now I've got a cosine with an invisible 1 that I'm not going to write. The other difference, though, is now I've got an x minus negative pi over 4, or x plus pi over 4. Still have a k value of 0 that we don't have to write, so this is our cosine version of this. For this one, I want an equation for this graph, so I'm going to do a sine and a cosine version of this. For sine, we have the general equation a sine of bx minus h plus k, so I need a, b, h, and k. For the a value, the amplitude, that's going to be half the height. So to find that numerically, I can do top minus bottom for y values and then divide by 2. So it looks like we've got, this seems to be 4 up here. This is down here a y value of 2. So we have 4 minus 2 over 2. That's really 2 over 2, which is 1. And just visually, we can see it does appear to be go up and down by 1 from the midline. For the b value, I need to find first the period and then divide 2 pi by that. So the period, it looks like this is actually exactly 1 full cycle of the graph. So how far are we going? Well, our x-axis grid lines are going by 1s. And it looks like we're going 8 grid lines to the right for that whole period. So that's going to be 8 for the period. The b value then will be 2 pi divided by 8, which I can simplify to pi over 4. Next, I'm going to go ahead and just go a little out of order and find the k value just because. So for that, I'm going to average the top and the bottom. So now I'm going to do 4 plus 2 over 2 to find the middle y value. And that's 6 over 2, which we can reduce to 3. And then finally, for the h value, Since we're dealing with sine, I need to figure out the x value where sine begins. That's, in general, the middle of the wave going up. So finding that on my graph, middle of the wave going up, that's right back here on x equals 0. So then my h value for sine, positive sine, that's going to be 0. Okay, so let's go ahead and put everything in there. We have y equals my a value of 1, so I don't have to write the invisible 1 there. I've got a sine times, or sine of a b value of pi over 4 times parentheses x minus 0, but I don't have to write the minus 0, so I'll just write x there. And now I have to add my k value of 3, and this is what the equation looks like if I use the sine function to describe it. Now I'm going to keep most of this information the same to do a cosine version of this. I am going to keep the amplitude, the b value, the k value, all of that will remain the same. But now if I do a cosine version of this, I need to change the h value so that I have the x value where cosine would begin, which is going to be the top of the wave. So looking at my graph, the top of the wave is right here at x equals 2, so that's my h value now, x equals 2. Plugging things back in, I still have an invisible 1 for my a value. Now I've got cosine of pi over 4 instead of sine of pi over 4. We have now x minus 2 in a parentheses next to that, and the value of plus 3 has remained unchanged outside there. To get an equation for this graph, let me start with the general formula for sine version of this, and then I'll do a cosine version. So we have a sine of b x minus h plus k. And then let me start finding all these different things that I need, a, b, h, and k. The a, the amplitude, that's going to be half the height. So I need to do top minus bottom y values and divide that by 2. So that's going to be, looks like 3, or actually 2 there, minus negative 1. So that's the whole thing comes out to 3. That's the height, and then I have to divide that by 2. So we have 3 over 2 for our amplitude, 1.5. That's how much we're going up and down to get to the middle, from the middle to the top and the bottom of the wave. Next, I need my b value. For that, I'm first going to need the period. So how long does it take this wave to repeat? The only repeating spot of the wave we see is the bottom of the wave here. And how many grid lines is that? Looks like we've got 3, 6, 10. So that's 10. Now each grid line is actually 1, so that's a grand total of 10 for our period. And then the b value is just going to be 2 pi divided, or actually, yeah, 2 pi divided by 10. And I can reduce that if I want to pi over 5. All right, I'm going to go out of order and just get the k value out of the way here. So that's the vertical midline of the graph. To find that, we have to average the top and the bottom y values. So I'm going to do 2 plus negative 1 instead of minus, because now I want an average, and then I have to still divide that by 2. So this is going to be a positive 1/2 for the k value. And just visualizing it on the graph, it looks like, yeah, at about 1/2, that is the middle of the wave vertically. All right, for the h value, that's going to be the x value where, in this case, the sine part of the wave starts. So sine always likes to start at the middle of the wave going up. And there's only one spot on the wave where that is. That's right around here. Now, if you're not sure exactly what that x value is, here's a little trick you can use in this problem. Since it doesn't seem to fall on a grid line, to find the middle of the wave going up, you're going to take basically the average of the x values for the bottom and the top of the wave, because middle going up is going to be halfway between the bottom and the top, just the way these things are set up. The bottom is at an x value of negative 3, and then the top is at the x value 2. So if you average those, negative 3 plus 2 divided by 2, that's negative 1/2 where you're at. So definitely not on a grid line. All right, we've got everything here. Let's plug it all in. We have y equals 3/2 for the amplitude there. Now we have sine of the b value pi over 5. And we have x minus the h value negative 1/2, so x plus 1/2. And then we're adding our k value of 1/2. So that's the sine version of all this. For the cosine version, I'm going to keep most of this information. The a, the p, the b, the k, all that is going to be unchanged. What will change is the h value, because I now need the x value where cosine likes to begin. That's going to be the top of the wave, which is right here. So this is going to be an h value here of 2, the x value 2 right there. Plugging all that into my cosine formula, I've got still an amplitude of 3/2, still have cosine of pi over 5, but now we have x minus 2 inside that parentheses, and we still have the k value of plus 1/2. Before I can graph this crazy looking sine function, I need to get a few features. One such feature is the amplitude, the amount that the graph is going up and down from the midline. That's this 4 out in front, the a value 4. And then I need the period, how long one cycle is. So that's going to be 2 pi divided by the b value here of 16, which I can reduce to pi over 8. Next, I need the h value to tell me where to start my wave, what x value. That's going to be the opposite of whatever's in here with the x, so negative pi over 32. And then finally, the midline, the k value, that's going to be this negative 2 over here, the constant. All right, so now let me get my horizontal and vertical window for my box that is kind of framing my one period of my trig function. So for the horizontal, I'm starting at negative pi over 32 for the x values, and I have to go 1 period's worth of x values to the right. So let's see here. What would negative pi over 32 plus pi over 8 be? Well, pi over 8 we can think of as 4 pi over 32. So negative pi plus 4 pi over 32 would be 3 pi over 32. And then vertically, I have to go from k minus the amplitude to k plus the amplitude. So at the minimum value, we have negative 2 minus 4, which is negative 6. And how high can we go? Negative 2 plus 4, which brings us to positive 2. So I need a graph that goes from negative pi over 32 to 3 pi over 32 horizontally, and from negative 6 to positive 2 vertically. Here's the grid lines for one graph that might do this. So let's see here. From horizontally, I've got a negative pi over 32 here, and if my grid lines are going by pi over 32s, here's 3 pi over 32. Vertically, I'm making my grid lines go by 2s, so I've got negative 6 represented down here, and positive 2 is up here. So it's time to go ahead and actually start putting some dots on here and graphing. Remember that I'm starting at the x value, negative pi over 32, so this spot right here is my starting x value. And since this is the sine wave, we start at the middle and go up. So we have to start at the midline here at negative pi over 32. Our midline, we said, was negative 2 for the k value. So we're right in the middle here at negative pi over 32. This is our first dot. And with sine, we have to go up for our first step to the right. So we're going to go up the amplitude of 4, bringing us to the top of the wave. Since we're at the top, now we take one step down as we go to the right. And we're at the middle, now we take another step down to get to the bottom of the wave, and now we bounce back up an amplitude step to the right. And then just draw the sine curve through those. Before I can go ahead and sketch the graph of this function, I'm going to rearrange it a little bit. I like things to be in a cosine b x minus h plus k form, so let me add this 3 over here so that I can read it like I normally would. Okay, now that I've done that, I'm going to pick out the a, p, h, and k values from this function so that I can graph everything. I need those to get my window that I'm graphing it in. The a value is this coefficient of 2. For my b value, I have pi over 2, so the p value then is 2 pi over 2. Same change flip in that thing. I'm really doing 2 pi times 2 over pi. Pi's are canceling. We've really just got 2 times 2, which is 4. For the h value, that's going to be a positive 1 because we have x minus 1 in here. And then for the k value, that's going to be this positive 3 right here. So vertically, I'm going to actually, let me do horizontally first. Horizontally, I'm going to start at my h value and go 1 full period to the right. So I'm going from the h value 1 to the x value 1 plus 4, so that's going to be 5. And then vertically, I'm starting at the midline and going down and up whatever the amplitude is. So we've got, at the bottom, we've got 3 minus 2, so 1. And we can go as high as 3 plus 2, so up to 5. So I need a graph that allows me horizontally to go from 1 to 5 and vertically to go from 1 to 5. Here's what one such graph could look like. So vertically, we're going by ones on our grid lines, and I've got 1 here and there's a 5 up here, so I'm going to be bouncing back and forth in there. Vertically, I'm going by ones, and I've got the beginning of my wave right here and the end over here at 5. All right, so now let me do the cosine curve. Cosine, remember, begins at the top of the curve. So top of the curve is up here at 5, and the beginning of the curve is the x value 1. So 1 comma 5 is our beginning spot. And then we're going to take 1 step to the right, and we're going to go down by the amplitude of 2. 1 step to the right and go down again until we get to the bottom of the wave. Now that we're at the bottom, we take 1 step over and 1 step up, 1 amplitude up, I should say, and then over and up an amplitude again, and then we just draw this 1 period here. To sketch this graph, let me begin by picking out my A, P, H, and K values. That'll help me get the window that I'm graphing this in. So for the amplitude, the A value, that's going to be the coefficient of the trig function. There's nothing out in front here except an invisible 1, so that's my amplitude, going up and down 1. And now for the period, that's going to be 2 pi divided by my B value. I don't see a B value here between the trig function and its parentheses, so there's an invisible 1 for that as well. So 2 pi over 1 gives me a period of 2 pi. Awesome. So now let me see here. I need the H value. That's going to be the opposite of what's inside the parentheses with the x here. So we have a negative pi over 2. That's the x value I'm going to start my wave at. And for the k value, that's what's being added over here on the right. But I don't see anything, so there's an invisible 0. So we had invisible 1s, we had invisible 0s. So this is a kind of a very low-level sort of simple function, but we still can use this framework to help graph it. All right, so let me get my window now. Horizontally, I'm going from the h value to one period to the right. So I'm going from negative pi over 2 for x values, and then at the far right, I have to add the period to get my last spot here. Negative pi over 2 rather, plus 2 pi. Well, that's like adding 4 pi over 2. That comes out to 3 pi over 2. Next, vertically, I'm going from k minus the amplitude to k plus the amplitude. So from 0 minus 1, which is just negative 1, to 0 plus 1, which is positive 1. All right, so I need a graph that goes from negative pi to 3 pi over 2 horizontally and negative to positive 1 vertically. Let me come up with some grid lines for that. So let's say we make this over here negative pi over 2, and if these are going by pi over 2s, then we can have 3 pi over 2 right there. And now vertically, I can just make this down here negative 1 and this up here positive 1, and that's pretty straightforward. So to graph the sine function, I have to start at the middle of the wave going up. So starting in this situation, the x value that we're starting at is this negative pi over 2, because that was our h value. So middle, remember, is the k value, so that's 0. That's the x-axis, the y value 0. So we're right here on the x-axis at negative pi over 2. This is the beginning of the wave. And now every step we take to the right, we're going to start by going up, but every step we take, we're just going to go up or down this amplitude of 1. So we go over step 1 and up 1. And then since we're at the top of the wave, now we're going to take 1 step down as we take a step to the right. And we can still keep going in the same direction. Now we're at the bottom of the wave, so we step back up as we take 1 more step to the right. And that gives us enough to graph 1 period of our sine function.